we're taking a look at area under the curve, right? One of these, one of the uses of integration. One of the uses of integration is that if I gave you something like this, if I gave you a function f of x, and I said find the area under the curve between 2 points. Between the points A and B, this area here, we can easily find that area, right, by integrating between the limits B and A, the function f of x with respect to x. That's all, right? So if I ask you to find the area between these 2 points, right, to find the area bounded by the curve and these 2 lines, that's what you do. That's it. Okay? So to find the area under the curve, we're using this here. Right, online, you all here now, right? You done? Yeah. Adrian, you listening? Right? Anybody who's not on the WhatsApp group? Everybody in all the WhatsApp, this WhatsApp group, right? Yeah? Everybody here, right? And you also have the Google form? Yeah. Everybody? All right. Good. Put it down. Down. Alexis, you send my WhatsApp, please. If you're not on the WhatsApp group, send my WhatsApp now, right? I'll have you one time, right? Right. So that's the way you find area, right? Sometimes you will see it worded a little bit longer. Find the area bounded by the curve, the x-axis, and the lines x equal to a and x equal to b. All right. So same concept, right? Find the area under the curve bounded by the x-axis, x equal to a and x equal to b. Right? Sometimes they put in all those words, but it just means the same thing here. Okay, it means this exact same thing here. All right, so let's try a small example. Right, hopefully you revise the integration. It should be easy, right? I'll give you a curve. Let's say the curve looks like that. The curve is y is equal to x squared. And I want you to find the area bounded between 1 and 4. Right? I want you to find the area, please. I put it out there. Maybe my calculator for me is what? Yeah, it's currently calculated. But I wanted to practice kind of the area, right? Because there's a kind of it. Right, let's see what chi end up with there. So the area is the integral between what values chi? 1, and the function, what go in here? X squared. Go ahead, look it out fast. Once again. Right, and I know plus C, right? So after I plus C. So what we got here? When you integrate x squared, add 1 to the power, divide by the power. That's it. All right. And then plug in 4. So that's 4 cubed over 3. And then plug in 1. Okay, so you plug in 4, work it out, plug in 1, work it out. All right, how much is that? 63 over 3. Yeah, 63 over 2. All right, so that's 21, right? But watch this here. Because it's area, we could write units squared. Right, we should write that, right? Because it's an area, we write units squared. Okay, unit squared represents a possible units for the area. Right, some other like let's forget how to integrate. Try next one, right? Before I give you some word. Find the area there. Yeah, x squared plus 1. All right, let's see what you got. So area is equal to the integral. Area is equal to the integral between 3 and 1. Remember, not every question will give you a diagram, right? It will say find the area bounded by the curve, the x-axis, and the line 3 and 1. Okay, same thing in finding, right? So don't let the words confuse you. So you have 3 and 1, and you have x squared plus 1 dot dx, right? And then you integrate it. Right? Once you start to integrate, remove this. Right? What's the integral of this side? X squared. And what's the integral of 1? Right, 1x. Right? When you reach there, plug in a 3. Right? 3 cube over 3 plus 3. And then plug in your 1. 1 cube over 3 plus 3. How much is that? How much? 10.7 units. Okay. And remember, you can check it in the calculator as well, right? Okay. Right, online, that's okay. Make sure we get 21 on. That's the last one. Cool. Sure, if you're online, I can share you on our own. We're back in school yesterday. Yes. It's easier. I know. Yes. I'll be number one. So, it'll let us check if Right, good job, Emma. Right, before I give you questions like this, just one thing I want you to note, right? Right, let's do a favor here, right? Watch what happens with this example here. Watch what happens with an example like this. Right? When you work it out, you'll be able to tell me what happened, right? You remember what sine looks like? What does sine look like? Sine looks like that, right? That's okay? That's what sine x looks like, right? So y is equal to sine x. I want you to do two things, right? This value is 0, this value is pi, this value is 2 pi. Right? Remember all that? Anyway, this means you have to work in radians, right? This means that you have to work in radians. Right. Here's how I do for me. I want you to do two things. Find number 1, find the integral from here to here of sine x dot dx. So I want you to work it out 0 to 2 pi. And then I want you to work it out separately. Work it out 0 to pi. Work out that. And then work out this. And then work out between pi and 2 pi. And you'll recognize something happening. Right? So what was the integral of sine x pi? I gave it some time when I came late this morning to revise integration. What's the integral of sine x? Yes, I'm tired. You know one other thing in integration. If you get it. What's the next thing in the name? Choice. Oh, sign on what? Oh Lord. Yeah. Sign on what? Right. And cos, right? So the integral of sin is positive minus cosine, right? So the integral of sine is minus cosine. And then plug in your value. I want you to do it 3 times. I want to see, I'm going to show you something that happened. Right? Please remember to convert the calculate to radians, right? So we work out 1, 2, and 3. Let's see what happens, right? You figure out how to do it or not? When you're gonna get a Casio, the one you huh? Oh. There you come. I go. Come last year. I about from there. Wait, I'm messaging the wrong group. I'm messaging for advanced group. Alright, that's my fault. I put that message earlier, you know. I messaged you for advanced group, right? Now I'm phone for sure. I'm seeing the wrong group. So I'm seeing that. Oh, wait. I got to go to the wrong class. What is 45775? And I think I must go a long time ago. Did I see it in Macedonia? Because I sent a Macedonia group saying I come in late. Please spend some time and go by. Oh, well. I'm a big boy guy this morning. Yeah, I got a chance to film. I hope it's survive. I'm a big boy. Something happened yesterday. Like, all night. I'm the one. Yeah, I pointed about this morning. Again, guys, some rules are trying to so, now I've played on it, but that one, the first one that I had. Yeah, but kind of blue one. Yeah, so. Yes, that's what like. I have a few. I want to that. I want to go to this one. I don't know. Yeah. Yeah. I can't remember what it's saying graph looks like. It's saying graph, but just it's to apply and right. I want you to work out each of those individuals and we're just see something happen. Right. You can really answer that way. What's that? Right. And remember, for those who don't like to convert to degrees, to radians, if you want, you can work in degrees. Just convert 5 into 5. Right? right? Upside down, what you get for the first one? Right? When you integrate sine, you'll get minus cos. And then you have to plug in 2 pi and 0, right? So that'll be cos, so that'll be minus. I put the minus on the outside, right? Cos 2 pi. And then I'm gonna plug in cos 0. How much y'all got? When you work out that? You got follow what's going on? No? When they integrate sine again, minus cos. And then what you do after? Plug in it 2 pi and then plug in it 0. And minus the values, right? Zero. Right. You're supposed to get 0. Okay? I want you to go ahead now and do the same thing using these values. Here's 2. Between 0 and pi is 2. Right. So now you get minus pi and 0 cos x. Right? And you plug in cos pi and you plug in cos 0. You okay with this? Nathan, are you okay with this? Yeah. And the last one, the integral between, check over this one. Check it over, everybody. Anybody lost and not getting any values? Put your calculator in radians, right? And find cos pi and cos 0, then minus them all. I have to try it quick. Do the last one then, part 3. So we got 2 units for this here, right? When you work out this, something happened, right? So we got 0, we got 2. What's here? What about the last one? Right, and do the last one. Same integration, you just have to plug in your values. So that's minus, right? So that's minus 2 pi on pi cos x. And then you're plugging in 2 pi and you're plugging in pi. So cos 2 pi minus cos pi. Right? And you should get minus 2. All right? So watch this here. If I ask you to find the total area here and here, should I get 0? And there's some area here, and there's also some area here. So I shouldn't get 0, right? Right? But when I work it out, I get 0. Anybody can see why I get 0?
Is it because like the area on the top is so positive?
Right. So what you would recognize that whenever you work out area above the x-axis, positive. Whenever you work out area below the x-axis, negative. Right? And if the shape's equal, right, then you will get the sum to be 0. Okay? So how do we solve that problem? Number 1, we have to know the sketch of some graphs. Right? There are some graphs, we have to know the sketch. And if we know the sketch, here's what you do. Right? Instead of doing this and getting 0, what you will do is you will say between 0 and pi of sine x, that's positive, but because you know this part is negative, you put minus the integral between pi and 2 pi of sine x. Right? So because you know it negative, right, you're not going to add them separately. You're going to the one that positive, leave it here, the one that negative, pi minus sign in front. And then you'll get your answer to be 4. That's okay? So there are some questions where you have to figure out that the part below the axis is negative. And the only way you can know that is that you have to know these functions. Right? So it's like I showed you how sine does look and cos does look. You have to learn those things, right? That's okay? So after all this, I want you to write this note down. Note that when finding the area, note that when finding the area, note that when finding the area below the x-axis, note that when finding the area below the x-axis, we include a negative sign. We include a negative sign in front of this integral. We include a negative sign in front of this integral. Right, but of course, the only function that you will get a quadratic, or you will get a sine and plus. Right? Those are the 3 graphs that you're supposed to do. You know how sine looks, how does plus look? Right? It starts at a max and then finishes at a max, right? And how does x squared look? Quadratic, right? You have to be able to sketch a quadratic and then determine if it's plus or minus. Okay? Right? So there are functions that, well, those are the only functions that it will ask it. Otherwise, they'll give you a sketch. Okay? So once you see an area below the x-axis, put a negative sign in front of it one time. Okay? Put a negative sign in front of it. All right. Let's see if we can try a few past papers. Right, let's start with that. Easy one. Did I do 12 last week? All right, let's start with assessment. I like this one. This combines last week and this. What is this? Okay, this. Anybody know the why?
Just even.
Huh?
Yeah, but.
No, I wanted to pick up the whole. I wanted to pick up the whole TV full screen. No, it's one full screen already. Whatever, it never really show anything. All right, okay. Anyway, we doing that. There's specimens number 6. Take a little read, but the problem is it combines what we did last week. So you know some of who don't pick up that thing called a notebook. Right? Yes. So we're doing a combination of what we did last week together with this week. Go ahead, have fun. You're welcome. Yes, one question. What do you mean by the y-axis? What's the equation of the y-axis? What's the equation of the y-axis? Y equals 0, x is right? X goes there. Go ahead. So it combines last week and this week. Have fun. This is specimen paper. Specimen paper. Right, I got it now. Okay. Come around. Right, well, it can look back, it can look back. Huh? Hurry up. Yeah, go. Yeah, go. Now, do anything else? Yeah. Which some people don't have. All right, so you already have the equation from last week, and then use that now to find part two. Technically, you did part one last week already. Right, so you're using part one and part two. Huh? Okay. I don't know if this is clear. What's the answer again, William? Y is equal to what?
I can say the time of dot dot everything is 2y that equals to 4x minus x squared plus 7.
Right, but leave it like this, in this case, right?
Then that's the x.
Huh? Thanks. So, thanks for the button. Dot set the button.
Yeah.
Right, do your thing now, integrate. What we integrate in between again with this? Right, between 0 and 5, very good. So you're integrating to get part two between 0 and 5. But you all see how last week and this week connected in a question. They asked us to find the equation and then use it to find the area. Right? If you don't remember what you did last week, you'll be lost this week to the others, right? Right, so that's the equation, integrate now between 5 and 0. Yeah. Yeah, yeah. Because under the curve, it's not under 2 minus x, it's under the curve. They get curve first and then integrate. But you're saying that. So integrate that, madam. If you do revise the whole. What do you think of that? 2x? Or what do you think of that x squared and 2? Okay. Right. That's the whole thing. How you think? Just integrating, sorry. Hurry up, go that quick. Someone who did no task with you, right? Well, right? Well, what's in that? Put it on. Finish. Come on. Huh? Yeah, no. Right. Right, so when you integrate now, you'll get the area, right? When you integrate 2x, you'll get 2x squared on 2. When you integrate x squared on 2, you'll get x cubed over 2 multiplied by 3. Right? Because what's right? X squared over 2 is the same as a half x squared. When you add 1 to the power here, you divide it by here. So you'll end up with x cubed over 6. And then the integral of 7 over 2 is 7 over 2x. So when you simplify it, underneath here is 6. Then plug in 5 and 0. So I got 5 squared How much is that? How much you all got there? Alright. Anybody get that? 65 on the tree? Yeah. Yeah, that's fucking whole body of the company. Don't want to create a good idea effect of whatever you sign. We're not using either of them. Anybody get our online? Right, nice Sebastian, nice to meet you. Right, let's go again. Right, I'll pass it on and watch everybody when this starting. I give you one just like this again, but you have to find the function and then integrate it, right? So you combine it last week and this week. Any questions online? Any questions here, William? All we're doing is applying integration and plugging in limit. Double? Okay, double. That's long. Are you writing first? Let's go again. Alright, 2012, number 6, A and B. They're not related for this. So do that. I'm gonna pass by it. Right, and I also. Yeah, this thing. But I'll do that. It marks up it to. And so be able to stick it.
But different screen share, it could get screen share. Yeah, but how to be different.
Set up.
To get screen share, yeah, but functionality.
Yeah, PDF. Okay. But normally I'm gonna share more. Gonna share the whole screen.
Well, maybe close, and I don't put it in there.
I don't want the PDF there. I don't have the PDF there. I don't have the PDF here. PDF is already on my iPad. I don't have the PDF on my other stuff.
No, but then you could have to go in, yeah, so.
Yeah, I don't have it. Right, so you have to find the equation. I am more interested in part 2, right? Did I do part 1 already? Last week? Second C, 3x minus 5. Yes? 3x minus 5 at the top. Great, understood. Okay. All right, let's focus on part two, please. So, part one. Integrate between 0 and pi on 3 to cos x plus 3 sin x. No, you don't. No, in this case. One. Let's do part two from our own, please. Getting us in part two. Hold on. So forget part one, let's do part two of it. Leave a little space, you can finish it up. Y is 2 cos x plus 3 sin x. X-axis between 0 and pi on 3. That's close. Between 0 and pi on 3, right? Hurry up now. Hurry up now, we have more to do. Integrate that fast. Right, start with the most clear one. Yeah, right? Right, integrate that quick picture there. Online you can message, okay, answers coming in already, right? Answers are coming in. It shows us here to be Wednesday. Yeah, really book to them make a really book. I'll take a picture by number phone. What is black marker on? I think Georgia reading book. Huh? Oh. Yeah. Right, take your time when you're integrating it, right? Right, so I've seen people making this little mistake, right? What you say earlier, when you're working out the integral, please be careful, right? The integral of cos x is sin x, so that'll be 2 sin x. The integral of sin x is minus 3 cos x. For some people doing this, nothing wrong with that. But please remember, you want to simplify it one time, right? So a minus and a plus is a what? Minus. Okay? So that is the integral. And then, watch here. This is one function. Okay? This is not two functions, this is one function. So you're plugging in pi on 3 here, work it out, and you're plugging in 0 here and work it out. Okay? So you will end up with 2 sine pi on 3 minus 3 cos pi on 3, right? That's the first part. And then you're minusing 2 sine 0, 3 cos 0. See the way this thing is now, I have nothing going on. So we adjust that three. How much is that again? What we're gonna end up with? How much? Minus positive. 3.2. 3.2. 3.23. You can work in every radians, right? Like remember, you have a sharp. So you have to work out this. You gotta work out this separate and then put it and plug it in on itself. Right? Right, for those with a sharp, my advice there is to work out this, and then put in the values. Work out this, put in the value, work out this, put in the value. Okay? If you have a sharp, it will read it wrong. So work it out individually. Right? And that's some of the problems. That's some of you all doing this thing properly. But when they use that sharp calculator, they get the wrong answer, so you think you're doing the wrong thing. Right? So you need to spend some time on perfect your sharp or try and get past you. Right?
Okay.
You know, probably a easy map to get through them.
Okay. Let's see if it makes up around.
But probably easy for them to get it.
They have a big difference there.
Anybody else got that value online? Ahmed? Alexis? You all got that?
Teacher,
You okay with this? Please, you okay? Let's go on, let's try one more. So when I'm all right, last one. Did I give it 20 next last week? Yeah. 19 or 7? 19. All right, try this one. This one will combine all these skills I have in the shop. Right, let's see how much skills you have there.
So what did from?
This is 2016 number 6.
Which one? Garment.
You have a genre.
Fine.
Right, try that in. Try to finish. Format.
So.
Up. X minus 2 all squared plus 5. What did it? Write it down fast, the equation, in case you not see it. Write this in. Oh yeah, copy down fast. Right, and then find the area. Find the area bounded between 1 and 2. Oh yeah. The trick is you gotta remember how to integrate things like this. Go ahead, have fun. Only one thing you have to do on the integral is. One thing you have to do. Online, I want to see some more answers, right? Who? Yeah, me not there. Elizabeth on the weekend. Done something F month. Right, x minus 2 squared plus 5. There's something you have to do before you start to integrate it, right? I'll pass on to what I'm saying. Second half, right? Alright, so the secret out, you have to expand this out, right? That's what you're now. Oh yeah, go yeah. Take your time when you're expanding it out, right? Oh yeah, expand it fast. They expanded the area.
Yeah.
Like, would be you could have the following. All right, let's see what you got. Right, so when you expand it out, you'll get x squared minus 4x plus 4 plus 5. So you get x squared minus 4x plus 9. And then to find r, you integrate between 2 and 1. Right? Then you integrate between 2 and 1. So that would be what? That would be x cubed on 3 minus 4x squared on 2 minus plus 9.
Yeah.
Right? Then plug in 2 and plug in 1. Yeah, yeah. Get you out of the- And then your minus is 1. How much you got? Ahmed got 58 and 3. But you get us? Oh. Plug it in away again. I have 1.33. 1.33. 400. 1600. But I can't do that. Oh, yeah, yeah, yeah. Put 13 on 3. They're looking like 13 on 3.
Yes, it's nothing, something.
That's 1 cube. Sorry. How much you got? 16 on? 16 on 3. 16 on 3. Right? Nice. So that's the way we integrate, right? I don't like how you all work today, yeah? Work a little slow. Please spend some time and go over integration, right? Next day, we have one more application and integration to do. That's the volume. All right? So just make sure you can integrate and make sure you're okay plugging in values. All right.